Go ahead.
Hello everyone. So today we're talking about exponential form. A little bit of review is that R right here is the modulus, and that's just how long this vector thing is. And the way we find this R is right here, a plus bi, that's just normal form. And so a plus b, right, I would translate here, 5 plus 5i. And so this is a, this is b right here, so a squared plus b squared, that's 5 squared plus 5 squared. Oh shoot, this is supposed to be an e. Okay, that's supposed to be an e, this is supposed to be an e right here. Okay, so this is that, and then the angle is pi over 4 radians. So this would translate to square root of 50 e to the imaginary I multiplied by pi over 4 radians. That's just exponential form right here. This is the normal one. And the reason we have exponential form is because of Euler's formula, and the reason we use it is because it's really easy to multiply together the two vectors or divide vectors, and then also raising them to a power. When we want to multiply things together, this would be equal to R1 EI theta 1 multiplied by R2 EI theta 2. That would equal R1 times R2, and then exponent rules, those two add together. And then this would essentially just be this. So when you want to multiply the two vectors together, just multiply the moduli together and then add the angles together. If you want to divide, R1 E I theta 1 divided by R2 E I theta 2. Again, using exponent rules, you do this, and then these two subtract together because exponent rules. EI minus I theta 2. And so this would equal this E I, and then so the angles subtract this time, and the moduli is divide. No. And so now that you guys know how to do these two, I would say do this one by yourself. I'm sure you guys can do it. You just raise everything. So right here, this gets raised to s. So you use exponent rules here, and then you just raise the moduli to the s power. What is R2? Yes, okay. So that's this is that, this is review, this is how to use it sometimes, if you want to multiply, add, or raise it to a power. And then on this side, on this side, so this is some cool stuff you can see with Euler's form. Right here, we have this weird thing right here. And that equals something pretty familiar. So another way to write Euler's formula is, if you remember, is writing it in polar form. And I believe that's cosine theta plus I sine of theta. Okay, so if we plug that in, substitute it, we get cosine theta plus I sine of theta. And then this is a negative angle. So that's cosine of negative theta plus I sine of negative theta. All right. And so let's remember what cosine and sine is. Cosine is an even function, which means that right here, x and negative x, they are equal. Cosine of x equals cosine of negative x. That means they're even because they equal each other. And if they're odd, sine of negative x is equal to negative sine of x. And this is odd because they're negatives of each other. So, using these rules that we now know, cosine of theta simplifies to minus cosine of theta minus I sine of theta, because sine of negative theta is equal to negative sine theta. And then that's divided by 2i. And So this time cosines cancel out. And so 2i sine of theta divided by 2i, the 2i's cancel out, and this is equal to sine of theta. So what we found here is that ei to the theta minus ei to the negative I theta divided by 2i, this is all equal. So sine of theta equals this weird function right here. And we can tell that because of Euler's form. And so right here, this is equal to something that's related to sine of theta somehow, a little bit. But I want you guys to do this one on your own. Because now you guys know how to do this one, you guys should be able to substitute it in and find it out with this, using Euler's form. And make sure you remember that the cosine is even, sine is odd.